Hello, today we want to see how we can make expression that is not a perfect square to become a perfect square. This is a quadratic expression, m squared minus 6m. For us to make it a perfect square, we need to add something to the expression m squared. We need to add a term to the expression m squared minus 6m to make it a perfect square. Now, a perfect square is obtained when a term is multiplied by itself. What is obtained when a term is multiplied by itself is a perfect square. For example, 6 times 6 is 36. 36 is a perfect square. So we have m squared minus 6m. This is not a perfect square expression. So we want to look what do we add to m squared minus 6m to make it a perfect square expression, so that it will become an expression that so that we are going to obtain an expression that if it is factored, the factors when the factors are multiplied by when the factor is multiplied by itself, you get back the perfect square expression. Now in this case we have m squared minus 6m. So let's go straight. Now if it's going to be a perfect square expression, let's call the term we are going to add to it to be k. The constant term that's going to be added to m squared minus 6m to be perfect square, let me call it k. So let the term to be added to make m squared minus 6m a perfect square be k. So we are going to add k to m squared to make it a perfect square expression. So in this case, as you can see now, now we have m squared minus 6m. So we say let the term be k. In this case we have m squared minus 6m. So we say let the term to be added to make m squared minus 6m a perfect square be k. So working with that now, this will be m squared minus 6m plus k. Assuming this is a perfect square, then we can use an identity for perfect square, that is m squared minus 6m plus k is equal to m minus a squared, right? So what I'm saying that we are using the identity for perfect square expression. So m squared minus 6m plus k is equal to m minus a everything squared. If this m minus a is expanded, then m minus a squared will give rise to m squared minus 2am, right? 2am plus a squared. All right, so now let's compare it with the expression that was given to us. we are given m squared minus 6m. They said we should find a term that will be added to m squared minus 6m to make it a perfect square expression. All right. So in this case, let's see, we have now comparing it to what I have just written here like this. So I was given, now to compare it with that now, we have m squared minus 6m plus k. So using perfect square identity to refer to compare it, this will be equal to 2am. It will be equal to m squared minus 2am plus a squared. All right. So I'm repeating it again for understanding. So it's equal to m squared minus 6m plus k equal to m squared minus 2am plus a squared. So looking at this this what is written now, the constant term at the left hand side is minus the coefficient of m at the left hand side is m. The coefficient of m at the right hand side is 2a. I repeat, the coefficient of m at the left hand side is minus 6. The coefficient of m at the right hand side is m. I said again, the coefficient of m at the left hand side is minus 6, while the coefficient of m at the right hand side is 2a. So we can now begin to compare the coefficient, right, of the m at the left hand side and the coefficient of m at the right hand side. So let's do comparison. So comparing, we have the coefficient of m at the left hand side as minus 6. So minus 6 is equal to the coefficient of m at the right hand side, which is minus 2a. Since the two coefficients are negative, all right, since the two coefficients are negative, the minus will go with themselves. That's because minus times minus minus is plus. So for that reason, this will give rise to 2a is equal to 6, right? So if 2a is equal to 6, then it means that 2a, although is dividing both sides by 2, 2a equal to 6 all over 2, dividing both sides by 2. This 2 go with 2, we are left with a. Then 6 divided by 2 is equal to 3. So in that case, it means that a is equal to 3. All right. Now with this kind of arrangement, well, we know that a is equal to 3. Now looking at what I've written, k is the coefficient of the constant term at the left hand side. That means the constant term here is 1, while a squared is the coefficient of the constant term at the right hand side. That also means that the constant term at the right hand side is also 1. So I'm going to be comparing the coefficient of the constant term at the left hand side and right hand side. So the coefficient of the constant term at the left hand side is k, and the coefficient of the constant term at the right hand side is a squared. So now the coefficient of the constant term at the left hand side, which is k, is equal to the coefficient of the constant term at the right hand side, which is a squared. From since we have known that a is equal to 3, it implies that since a is equal to 3, then k, which is equal to a squared, and a is equal to 3, then k now is equal to 3 squared, because they say k is equal to a squared. So that a there is 3. So a squared now is 3 squared, which is equal to 9, right? So therefore k is equal to 9, right? K is equal to 9. So that means the constant term, the term that should be added to m squared minus 6m to make a perfect square is 9. Because from here we say let the term to be added to make m squared minus 6m a perfect square be k. Now from all this, what we have manipulations here, we have gotten the constant term, which is k, to be 9. The constant term to be added to the original expression, m squared minus 6m to be a perfect square expression, is k, and that k is 9, right? So now let's add it and see. So when it is added, when it is added, then m squared minus 6m becomes m squared minus 6m becomes a perfect square, right? What I'm trying to say here, this is the m squared minus 6m, so I'm going to add the k to it now. So m squared minus 6m plus k, this is now a perfect square. All right, it is now a perfect square expression. It's not a perfect square expression. All right, so m squared minus 6m plus k, it is now a perfect square expression, right? So sorry, so m squared minus 6m plus k, m squared minus 6m plus 9 is now a perfect square expression. So m squared minus 6m plus 9 is the perfect square expression. So I'm still writing it again for clarity. M squared minus 6m, right? When I add the 9, which I got as the constant term, if I add it to this, I have gotten a perfect square expression. That means m squared minus 6m plus 9 is now the perfect square expression we are talking about, right? So now if we factor this expression, we are going to have m minus 3, right? M minus 3 squared, right? So if you expand this becomes this, right? If you expand it, give rise to this. So for m squared minus 6m to be a perfect square, the term that must be added to m squared minus 6m to be a perfect square is 9, right? So in this case, as you can see, m squared minus 6m plus 9 is now a perfect square, right? So if you factor it, it will give you m minus 3 squared, all right? That is what I'm trying to say now. You can check it. To check, you discover to check. If you check, you discover that m minus 3 squared, when it's expanded, it will be m minus 3 times m minus 3, which will give us m squared minus m squared. Okay, let me just take it step by step. M times m give us m squared, then m times minus 3 give us minus 3m. Okay, so m times m is m squared, while m times minus 3 give us minus 3m, then minus 3 times m give us minus 3m again. Are you seeing it? So m times m is m squared, then m times minus 3 is minus 3m, minus 3 times m is also minus 3m. Okay, so minus 3 times minus 3 give us a plus 9. Okay, now this is equal to m squared minus 6m plus 9. Okay, so for m squared, so you can see that we have gotten back the perfect square expression. So initially m squared minus 6m was not a perfect square expression, so we were asked to find a term that's going to be added to m squared minus 6m to make it the perfect square. So at the end of the manipulation here, we got the term to be added as 9. It's going to be added as 9. So now we have m squared minus 6m. So when we added this, now we have m squared minus 6m plus 9 for it to become a perfect square. For you to check whether it's a perfect square expression, you factor it. When you factor it, you arrive at m minus 3. Just like how 9, which is a perfect square, is 3 squared. Alright, that is 3 times 3. Thank you. Okay, so I will say just like how 9, which is equal to 3 squared, 9 is a perfect square expression. Just like how 9 is 3 squared, which is a 3 times 3. So if there's any comment, go ahead and leave it in the comment section. Hope to see you again in my next video. Thank you.